Hello everyone, welcome back to our channel. Today we are going to solve a very popular LeetCode problem, and that is sort colors. So it is very frequently asked in interviews, and it will test your ability to solve array manipulation problems. So let's delve into the problem statement first. So here it is written that you are given an input of array, okay, like this nums equal to an array, and which are with n objects. So there are each number is identified by a color red, white or blue. Okay, so later we'll find that we'll use 0, 1 and 2 to represent the color red, white and blue. So 0 is represented by red, and 1 is represented by white, and 2 by blue. Okay, so we have to sort them in place so that objects of the same color are adjacent with the colors in order red, white and blue. Okay, so all the red colored objects, that is 0 colored, should be placed together. All the white color objects, that is denoted by number 1, should be placed together, and as well as blue, right, which is denoted by 2, should be placed together, and they should be sorted in such a way that all the red should come first and then white and then blue. Like here in this example, if you see, the output should be like this, right? 0 are red color, so they came first, and then 1 and then 2. Okay, so these elements are rearranged such that it follows this pattern, right? So red, all the red element, and then all the white element, and then the blue. Okay, and here if you see in this problem, so first thing that comes in mind is simply using the sort, and then it will get sorted, right? But the problem says that you should not use library sort function. Instead, without using sort function, you should do it. Okay, so there should be some better way than I mean sorting complexity. So there should be some better way in login. We should try that. So here if you see in the input, right, so 202110, all the 0 comes together, and then the 1 and then the 2. So here in the second example also it is the same, right? All 0 comes first, 1 and 2. So if you see in the constraint, then it says that number can be either 0. So your input will always have red, blue and white color only. It will not have any invalid input, right? And follow up, could you come up with a one pass algorithm use constant extra space? Okay, so let's look at the problem statement first and the approach to solve this problem. So since we can't use sort algorithm, other things that comes in our mind is creating a new empty array, and then iterating. In the first iteration, we'll go through all the elements and see if there are 0, then we'll store that 0 in the new array, and then in second iteration one more time we'll iterate, and then we'll see if there are 1, then we'll edit 1, and again third time again one more time we'll iterate, and we'll look in the third iteration, we'll look for 2 and we'll add that 2. Okay, so these will result in 3 pass algorithm, right? First iteration for I to n, right? So we'll look for 0, and then we'll store in our result, right? We'll store all the result 0, and then in second iteration we'll do it for 1, and in the third iteration we'll do it for 2. So in this way we are using 3 pass, right? We are doing thrice, and also we need a new space to store all these values, right? But here what they are asking is like, could you come up with a one pass algorithm? So instead of doing it 3 pass, could you do it in 1 pass? Okay, and also using only constant extra space, so without using an extra resultant array, could you do it in constant extra space? So what they mean is like modify in place, right? So do not return anything, like modify nums in place, right? So nums is your input, so you have to modify in that nums only instead of using an extra space. So to solve this problem, we'll use a very popular algorithm called Dutch national flag algorithm. So what this algorithm says is that we'll have two pointers, low and high, and all the elements, right, uh, that are less than that are 0 should be before low, okay, and all the elements that is 2 should be after high, okay. So all the 0 elements should be before low, and all the 2 elements should be after high, okay. So the remaining would be 1, so it will come in middle, okay. So this Dutch national flag algorithm is used to arrange three colors. So it's a very popular algorithm by Truss. So let's see how it can be achieved, right? So suppose, for example, if you take this input, right, 202110, 2021110, right? So to solve this using Dutch national flag algorithm, what we'll do is we'll have a low pointer which will point to our initial, in the beginning of the array, and high pointer which will point to the end of our array, okay. And we need one more pointer which will iterate through, right? So our algorithm says that whatever comes, all the zeros should come behind low, and all the twos should come after high, okay. So we need one more pointer which will iterate, and let's call it mid, okay. And this will also point to our at the initial position. So this mid will point to our initial position in the beginning, okay. So now what we will do is we'll keep on iterating this mid, and at any point of time, if we'll find 0, then we'll put it behind low, and if we'll find 2, then we'll put it after high, okay. So for example, this mid is pointing to 2, and it says that 2 needs to go outside this, uh, what do you say, after this high, right? So at this point of time, what it does, it will just swipe this value. It will not see what value is there in the high, right? It will just swipe it here. So this 0 will come here, and this 2 will go there, right? And at the same time, since we have swapped it, so now I have to decrement my high, because now I know that the original place of 2 is here only, right? So I'll have to decrement this high. So just decrement, and it will move here, right? So and at the same time, mid will still be pointing to 0, because there might be I mean, what if, suppose, for example, instead of 0 it was 1, right? So 1 could have come here, and if mid moves to next, then it is not considering that 1 value, right? So it will be wrongly placed. So mid will still be here. Now second is, it will once again check, and now it sees that it is 0, right? So here what it will do, when it sees that it is 0, then now it can move forward, because now it knows that 0 is already placed here, so it will move forward, okay. Or rather, I would say that mid has found 0, so it will swap with low, and swapping with low will place the 0 in its same place. So that's why the mid will go here, and at the same time the low as well, because 0 is correctly placed, and now it says that 0, all the 0 should be behind low, and all the 2 should be behind high. So now, since it has checked this and it has found that it is 0, so it should go behind low. So low moves forward, saying that 0 has been forward. So in our, these are second iteration, right? In our third iteration, mid finds that it is 0 again, right? So it will swap with low, so it's at the same place, and it goes ahead, right? So when it goes ahead, it will it will go here, and at the same time low also moves forward. Okay, so saying that it has all this 0 is also sorted, saying that this 0 also should go behind low. Now mid will see that it is 2, right? So when it found it 2, then it knows that it needs to go behind high. Okay, it will swap this 2 with swap the mid's value with the high. Okay, so here it will remove it, and here it will remove it, and 2 comes here, right? 1 comes here. Okay, so when 1 came here, then high, so we know that we have moved 2 from here to the end, right? So in order high is sorted, or maybe the 2 has moved, just now it has changed, so that's why I have to decrement high. Okay, so decrementing high, and now I'll say that now mid is 1, right? So when mid is 1, it will do nothing, right? It will do it will perform only for 0 and 2. If it is 2, then it will move after high, and if it is 0, then it will move behind low. For 1, it will do nothing. So next iteration, this mid will move here, and now it sees that now it sees, it finds 1 once again, and it also sees that it has reached a high value, right? So now our task is over, now we are done. So we'll iterate this till it reaches the high. Okay, because we know that after this high everything is sorted, so I don't have to move forward again. So after this high, I know that only the 2 values will be there after high, right? So that is our approach to solve this problem. Okay, so let's do the coding now. So first of all, I need 3 pointer with low and mid pointing to the initial index, that is 0, and then we have a high pointer which will point to the end of the array. Okay, and what we will do is we will iterate the mid till it reaches high. Okay, while mid is less than high, and we have three conditions here. First, if it is if the so mid is our iterator, right? So if the mid value is 0, then if 0 is encountered, then it would be nums of low and nums of mid would be swapped. Okay, at the same time we must increment our low value as well as mid. Okay, elif nums of mid is equal to 1. So if it is the mid value 1, we don't have to do anything, we'll just have to increment our mid iterator. Okay, and finally we are left with 2 value. So when nums of mid equal to 2, what we have to do is we'll have to swap with the high value. So when it is 2, then we'll have to move the 2 to the after the high. Okay, so to do that, nums of mid and nums of high needs to be swapped first. Mid, and finally we'll have to decrement our high value, high iterator. So initially when 0 is encountered, then we'll have to put this 0 behind our low. So that's why we're swapping with low, and then we are incrementing low so that 0 stays behind the low, and we are incrementing the mid as well. And then next, if it is 1, then we don't have to worry about the middle element. we'll just increment the middle plus 1 because it says that it is in place. And when it is 2, then we'll have to put that 2 after high value, okay, after high pointer. So that's why we are to do that we are just swapping mid with high, okay, and after swapping we are decrementing the high value so that all the 2 values stays after high, okay. So that is the core logic of our algorithm, and finally we can return our nums, okay. So this is our final algorithm. Unpack non-iterative table. Okay, sorry. So missed out here. We have to initialize low and mid as 0 and 0. Okay, so low is 0 and mid is 0. And I think I'm missing one more thing, that high should be the last index, right? So it should be length of nums minus 1. Okay. Here if we see nums equal to 201, output is 102, but it should be 012. So what did we do? Mid is less than high. We'll have to check, so here I'll have to check this value as well, okay. So because we have initially we have swapped this and this, and we know that everything that is after high is 2, but we don't know what is high pointing to. It can be 0 as well, which needs to be swapped there. So I think it should not be till less than, it should be equal to, right? So until it reaches the high pointer. Yes. Okay, perfect. So that's how we have solved today's problem, and now we are done with this algorithm. So thank you so much uh, mm, for having your patience, and I'd like you to give us a thumbs up and also subscribe to our channel. And if you have any doubt or suggestion, please put it in the comment box. We'll meet you in the next video. Thank you so much. Thanks a lot.